The square root method. The steps are isolate the variable or quantity that is being squared. Take the square root of both sides. Remember to add plus or minus to the constant side. We'll split that into two equations and then solve each of those equations independently. Example number 3. Let's use the square root method. Notice that x squared is by itself. That quantity x is being squared. So to undo the square, we'll simply take the square root of both sides. And x is equal to plus or minus the square root of 9, which is 3. So we have our answers, 3 and negative 3. In the next example, we need to isolate the squared quantity first. 2x minus 3 is being squared. We need to isolate it. That means we need to first add 1 to both sides. 2x minus 3 squared is equal to 9. Notice now we've isolated the quantity that is being squared. We want to undo the square, so we're going to take the square root of both sides. 2x minus 3 is equal to plus or minus 3. Don't forget the plus or minus on the 9. The square root of 9 is 3. Just don't forget the plus or minus. So at this point, we can split it into two separate equations. 2x minus 3 is equal to negative 3, and 2x minus 3 is equal to positive 3. Add 3 to both sides. In the first equation, we get x is equal to 0. Add 3 to both sides over here as well. Divide by 2, and we get x is equal to 3. In this one, we need to first isolate the squared quantity. To do that, we're going to subtract 4 first. Then we need to remove the negative, so we'll multiply both sides by negative 1. That's just going to switch the signs. At this point, we've isolated the squared quantity. Take the square root of both sides. We get x minus 4 is equal to plus or minus the square root of 1, which is 1. Here we'll split it into two separate equations and solve these independently. Add 4 to both sides, and we get 5 and 3. Next, completing the square, find the missing constant that would create a perfect square trinomial. The way we complete a square is we're going to take b over 2 and square it. And this is what we need to add in to create that perfect square trinomial. So in this first example, b is 6. So we've got 6, we're going to cut it in half and then square it. That's 3 squared, which is 9. So we're going to add 9 to force this to be a perfect square trinomial. Now, all a perfect square trinomial is when we factor it, you have two identical factors. So we could factor this as x plus 3 times x plus 3, which is x plus 3 squared. So in the next example, b is negative 10. So we're going to take b over 2 and square it. Negative 10 over 2, we'll square it. Negative 5 squared is 25. So we'll add 25 in, thereby creating a perfect square trinomial. And again, a perfect square trinomial means that when we factor this quadratic, we'll get two identical factors. In this case, x minus 5 times x minus 5, which we can simplify as x minus 5 squared. In the last case, b over 2 squared. b in this case is 5. So we'll take 5, cut it in half, and square it. That is 25 fourths. So when we add 25 fourths, we have now created a perfect square trinomial. This can be factored as x plus 5 over 2 times x plus 5 over 2, which we can then rewrite as x plus 5 over 2 squared. Now, it may not have been obvious right away that 25 fourths is going to generate this 5 over 2 when we factor it. The nice thing about completing the square is the number b over 2 before you square it is the number that will always end up in our factored version. Notice -5 here before we squared it is here. 3 before you square it is here. So b over 2 will always end up in our squared version. Let's try a full-on example of completing the square. The first thing we want to do is move the constant to the far right. So I'm going to add 15 over. Now our goal is to replace this blank spot with a number that will create a perfect square trinomial. To do that, we're going to take b over 2 and square it. b in this case is 14. Divide it by 2. 14 divided by 2 is 7. Square that and we get 49. So 49 is what we add in to the left side. If we add it into the left side, we now need to add it into the right side as well to keep our equation balanced. That's going to create a perfect square trinomial, which we can factor as x something squared. That something will always be the number over here, b over 2, before you square it. So in this case, 7 is what we add in to the parentheses. And then combine like terms on the right side. 15 plus 49 is 64. From here, we will use the square root method. Square root of both sides. X plus 7 is equal to plus or minus the square root of 64, which is 8. And from here, we have two different equations. X plus 7 is equal to 8. X plus 7 is equal to -8. X is equal to 1. And x is equal to -15. In this next example, we want to complete the square again. In order to use completing the square, we need to first make sure a is 1. In this case, a is 4. So we need to remove that 4. We can do that by dividing every term by 4. X squared minus 3x minus a quarter is equal to 0. Next, we'll move the constant over. X squared minus 3x is equal to 1/4. Now we need to add in a number to force a perfect square trinomial. That number is always b over 2 squared. b in this case is -3. So we'll cut that in half and square it. We get 9/4. So we're going to add 9/4 to both sides. That creates a perfect square trinomial, which we can factor as x something squared. And again, that something is always b over 2 before you square it. In this case, b over 2 is -3. 3 halves. Combine like terms on the right side. 1/4 plus 9/4 is 10/4, or 5/2. At this point, we have a quantity that is being squared. We can take the square root of both sides, giving us x minus 3/2 is equal to plus or minus the square root of 5/2. From here, we can set up two separate equations. X minus 3/2 is equal to negative root 5/2, or x minus 3 halves is equal to positive root 5/2. Add 3 halves to both sides. And this one as well, we'll add 3 halves to both sides. And we have our answers.